Hello, Math 120 students, I'm back, and we are now looking at 6.3, complex fractions. A complex fraction is just a fraction within a fraction, okay? So, complex fraction can be, let me just go to, we're gonna look at two methods on how to simplify complex fractions. So I'm going to just start out with an example. Let's say I have t plus 4 over 3t, and that whole thing is my numerator, and that's over 2t plus 1 over 9t. Method 1 is simply do the division. Remember, your fraction bars are like division. So method 1 is just treating this like a division. T plus 4 over 3t divided by 2t plus 1 over 9t. Okay, we did those in section 1. We're going to multiply by the reciprocal. So this one stays the same, times 9 over t, 9t over 2t plus 1. All right, simplify. Once you get into the multiplication stage, you can simplify before you multiply. So I see the common factor of t, and then a common factor of 3. So if I multiply, I have the 3 times the t plus 4, and on the bottom, I just have a factor of 1, so that's just t plus 1. That's it. Okay. That is method 1, where we just do the division. Method 1 is the best to use when you have a single fraction over a single fraction. Now, if I have something like this, 5 minus 2 over y over 4 plus 1 over y. Notice that I have two terms in the numerator and also two terms in the denominator. If I have two terms or more anywhere, method 2 is the best to use. Method 2 is using the LCD to clear the fractions. So I look at all of my denominators and I can see that it's just y. So y is the LCD. So the first thing to do is to find what the LCD is, and now I'm going to multiply both top and bottom of my complex fraction by the LCD y. So it looks like this. I've got my 5 minus 2 over y, 4 plus 1 over y, and I'm multiplying this entire numerator by y and the entire denominator by y. Distributing on the top and the bottom. Okay, we distribute to all the terms, and this is what we have. Y times 5 will be 5y minus y times 2 over y. Notice that that's going to cancel the denominator. So that would be, for just the numerator, 5y minus 2, because the y canceled right here. In the denominator, again, y times 4, 4y, distributing that y times 1 over y, the y cancels the denominator. So in the denominator, I simply have 4y plus 1. So the whole idea behind multiplying by the LCD is that any denominator in the complex fraction is going to cancel out. Now, once I get here, I would double check to see if there's any more simplifying I can do by factoring, and there is not, so I'm done. Okay, so again, method 2, if you have more than one term in either place, you want to do method 2. Clear the fractions by multiplying through by the LCD. All right, let's look at a couple other examples. Okay. I have 1 over p minus 6 all over 5 over p squared minus 36. So notice that this is a single fraction and this is a single fraction. So we're going to use method 1. Do the division. 1 over p minus 6 divided by 5 over p squared minus 36. We need to multiply by the reciprocal. So 1 over p minus 6 times p squared minus 36 over 5. Now we can simplify before we multiply, but that's going to require us to factor the difference of 2 squares there. So this one stays the same. There's no factoring to do there. This p squared minus 36, the difference of 2 squares over 5. So you can see that I have a common factor of p minus 6 that divides out. So when I multiply now, I have 1 times p plus 6 will just be p plus 6, and then 5. Okay, so we used method 1 because it was a single fraction over a single fraction. Okay, one more example, and we can call it a day. This is example 4. 1 over m squared minus 1 over n squared all over 1 over m plus 1 over n. All right, now notice I have 2 terms in the numerator and also 2 terms in the denominator. So this one's going to use method 2. Clearing the fraction. So I need to find the LCD of all of these fractions. I've got an m squared, I've got an n squared, I've got an m, and I've got an n. So I've got m's and n's, and I simply use the highest exponent. The LCD is m squared, n squared. So I'm going to multiply. I'm going to rewrite this so I don't mess with my original, so we can still look at that. Okay, so there's my original. I'm going to multiply top and bottom by that LCD, m squared, n squared. It needs to be distributed to all the terms, top and bottom. So this is what it looks like. Again, I'm going to write out all of my steps. You know I like to do that. I don't like to skip steps when I'm first looking at something. So now I have m squared, n squared times the first one, m squared, n squared times the second one. So I distributed the m squared, and that's what I got so far. I didn't simplify anything yet. Let's do the bottom. M squared, n squared times the first one, plus m squared, n squared times the second one. All right, now I'm going to simplify. Okay, so let's go look at what I have on top. So notice I have an m squared that can be divided out. The denominator will always divide out if I have multiplied by the LCD. So n squared times 1. Now here the n squared divides out. M squared times 1. We're subtracting, so that's all I have in the numerator. Now on the bottom, I have an m. Now I've got m squared and a single m, so I'm left with an m here. So I have mn squared for that first one. Plus, and now I have a single n and an n squared. So the single n, I'm going to be left with an n. So m squared n is my denominator. Now, let's see if we can simplify that. The numerator is the difference of two squares. So that can factor. It will factor if I come over here. Okay, n squared minus m squared, n minus m, n plus m. Difference of two squares. The bottom, I have a greatest common factor, mn. So I'm going to take that out. What am I left with? I took out the m, so I'm left with a single n, plus, see, I took out a single m, so I'm left with an m, and I took out that n. So that's all I have. Double check by multiplying back. mn times n, mn squared. mn times m squared n. That's hard to say. So now you can see that we have this common factor, and it will divide out, leaving us with our final answer, n minus m over m times n. And there is that, oopsie, sorry, problem. Okay, so keep it simple. Use the two methods. Look at what you have. Make your decision, and if you want to use method 1, because they're single fraction over single fraction, you just do the division. Or method 2, when you have more than one term in either place, then we can cancel the denominators. Otherwise, if you don't do it this way, you have to write this as a single fraction, write that as a single fraction. It's going to create a lot more work by having to rewrite the fractions over LCDs, combining them as one, and so on and so on. So choose wisely. Okay, let me know if you have any questions.